Okay, so we are looking at molar mass. This tool, this conversion, is used to go between grams and moles of a chemical, all right? So molar mass can be used to convert between moles and grams of the same chemical. So what we did in our last class, we looked at mole ratios. The job of our mole ratio was to change our chemical, but we kept the units the same, okay? Now we are going to be changing the units, but keeping the chemical the same. Okay, we can only change one thing at a time, basically, right? One or the other. So we use molar mass, and we use this because there is not a piece of equipment out there that can measure moles. It does not exist. But we can easily measure grams. So for instance, our value in our warm-up, if I actually wanted to do the reaction from our warm-up, and I wanted to measure this 0.251 moles of H2SO4, I don't have a piece of equipment for that. But I could change it to grams. I could do some math, change it to grams, and then I can figure out how much to actually weigh on a balance. Okay? So that's why we need this step, why we need this tool, because we have to use the equipment we have and what exists. So let's review what molar mass is. Flip in your notebook back to, it's in the last unit right before your review, right before your blue page. There's a pink one. So flip back in your notebook. No, I mean really. Like everybody, flip back before your review, molar mass, for the blue page. All right, so there we looked at calculating molar mass. We took some notes on molar mass. So what is molar mass? Beautiful, the mass of 1 mole of any substance. Okay, molar mass, mass of 1 mole of any substance. How did we calculate it? Or where did we get our numbers from? Let's start with that. Periodic table. Okay, so our periodic table has the molar mass of each element. So if I looked at hydrogen, what's hydrogen's molar mass on the periodic table? 1.01. So if I measured out a mole of hydrogen, its mass would be 1.01 grams. Okay? Well, if we had a bigger chemical, like say it was carbon dioxide, CO2, we'd have to add up the mass of a carbon and the mass of 2 oxygen and add that together, right? And that would be our molar mass. So we've calculated that before, but now we're going to use that as a tool to change units. So yesterday we used mole ratio as our tool. Now we're going to use molar mass. Okay? So we're going to go ahead and look at an example of this. We're going to use carbon dioxide as our example. So go ahead and write our example down. Okay? So how many grams of CO2 are there in 87 moles of CO2? Yeah, 87. Sorry, my handwriting got a little messy. All right, so our approach to these problems is going to be the same approach we took yesterday. We're going to be finding our given, what we're looking for, setting up our railroad tracks, all of that. The big difference is going to come in what units we write down and where we get our numbers from, okay? So let's take a look. In this question, what are we given? 87 moles of carbon dioxide. And what are we looking for? Grams of carbon dioxide. So is the chemical changing? No. What is changing? The units, the amount. So we're changing how we're measuring it, basically. So just like yesterday, we're going to go ahead and write down our given amount first. We have 87 moles of carbon dioxide. And we're going to set up our railroad tracks. And what's the next step we always do? Yep, we're going to copy that unit down to the bottom. Good. So moles of CO2 on the bottom. And then what do we want on the top for this one? grams of CO2. That's what it's asking for. So just like our other questions, the units really control everything. We want to write those units in first so we're not trying to guess where the numbers go. So now we need some numbers to fill in here. What we need is the molar mass of carbon dioxide, okay? So we're going to do a little side thing, molar mass. Now, before, when we did this in the last unit, we introduced it. You had to show all your work for molar mass. You don't have to do that anymore, okay? If you need to do it as a side calculation, you're more than welcome, but we can just do it in our calculator. So we need the molar mass of carbon dioxide. How many carbon do we have in this? 1, okay? So we got 1 times, just to see how we can put it in our calculator. What's the mass of carbon? 12.01. We use it a lot, so we get it memorized, right? Okay, plus how many oxygen do we have? 2 times what mass for oxygen? 16. All right. So we get that, we add it together, we get 44.01 for carbon dioxide. So the molar mass of CO2 is 44.01. I'm just going to put that to the side. Now, what units do we attach to that? Grams per mole. So let's see how that's read. 44.01 grams per mole. When we say per mole, how many are we talking about? 1. So it's this many grams in 1 mole. That right there is a fraction. It's a ratio. So we can read it as 44.01 grams in 1 mole. Or in 1 mole, there are 44.01 grams. You can change it up. So those are our numbers that we want to fill in. Because my grams are here, I want 44.01 grams. Right, next to the grams. And we say per mole, we're saying in 1 mole. So I'm going to put 1 on the bottom. So this part here is our molar mass. Oops, molar mass. That fraction right there is our molar mass. We okay with that idea? Okay. So, what can we cancel? Units. Moles of CO2. What are we left with? Grams of CO2. Okay, which is conveniently what we're looking for. And then we need to do some math. What do we need to do with our values? Multiply. We're dividing by 1. All right, let's go ahead and multiply, see what we get. You guys got a calculator? You can use your phone for that. All right, what do we get? 3,800 and what? 28 point something, right? All right, we can round. It's fine. All right, we got like 2 digits here. That's plenty. All right, 3,828 grams of carbon dioxide. So, if I'm doing a reaction and I need 87 moles of carbon dioxide, I don't have a piece of equipment to measure that, but I can measure instead 3,828 grams of carbon dioxide, which is a ridiculous amount of carbon dioxide. All right, so that's how this works. Same process, we're just using different numbers because we have a different goal in mind. All right, let's try out another one. Let's write that example down. We have how many moles are represented by 75.6 grams of C8H18. So this is called octane. This is what's in gasoline. All right, so what are we given in our question? All right, good. 75.6 grams of C8H18. What are we looking for? Moles. Does it mention? Of course. Yes, that is. Hi. Say they want to see you in the nurse's office to do your vision and hearing test real quick. Do you know where that is? Go to like attendance and tell them you need to see the nurse. Done that. All right. Where were we? Okay, so we've got grams of our chemical. We want moles. It doesn't mention any other chemicals, so we're just changing units. All right, what should we write down first? Good. 75.6 grams of C8H18. And we can set up our RoboTrucks. All right, what are we going to put on the bottom? C8H18. And on the top? Good. All right, so we can see here, chemical stays the same, but our unit changes. So we need the molar mass of that chemical. So let's do a little side calculation here. All right, how many carbons do we have in it? 8 times, what's our mass of carbon? 12.01. Plus, how many hydrogens? 18 times, what's the mass of hydrogen? 1.01. So we get a total of 114.26 grams per mole. All right. So, where's the 114.26 going to go? All right, here on the bottom. And you said what, Betsy? With the grams. Good. It's always going to go with our grams. 114.26 grams. That's how we read it. Per mole. So how many moles? 1. Good. We all right with that? Okay. So we can cancel. We can multiply and divide. Let's go ahead and do that. Let's try it out. See what we get. What'd you guys get? 0.66? All right. 0.66 what? Moles of? Good. C8H18. All right. Octane. So if I measure out 75.6 grams and I want to like do a reaction with it, I want to maybe figure out how much product's made from this reaction, something like that, then I can change it to moles and then maybe do a mole ratio or something. Okay? All right, we're going to do one more. I want you guys to go ahead, write this one down, and try it out on your own. Setting you free. So write it down, try it out. That is a 15 point. Let's go with 7.5. My bad. You've already got worse and worse. All right, so what did you guys put on the bottom for your units? Mole H2O. What did you put on the top? Grams of H2O. All right. For your molar mass of water, what did you find it to be? 18.02 grams per mole. And by the way, with molar mass, we never round them. We like all the digits, all right? So where are we going to put the 18.02? On the top next to the grams. So 18.02 grams in 1 mole, okay? So the grams, the value always goes next to the grams, and it's always 1 mole. Okay, what cancels? Units, moles of water. And what did you guys get? $283? 83 grams of H2O? All right. We agree? Sounds good. How are we feeling about this? All right, so we've got 2 tools so far. We've got mole ratio, we've got molar mass. We're only doing one at a time right now. We will mix them up. We will use them together later. When you look at your practice, I just put it away. Dang it. I'll borrow yours real quick, Leah. Thank you. Just to point it out. All right, when you look at your practice, it has a balanced reaction at the top. Now, did we use a balanced reaction at all in our notes? No. So are we going to use it for our practice? No. We're just kind of building up the skills. You do have space at the top to do your molar mass for each of the chemicals. So we're kind of just putting it in context of reaction. If I need to calculate this molar mass, am I going to include a coefficient? No, I am not, okay? Do not include the coefficients for the reaction. Just find the molar mass of that chemical. And we need units on them, okay? And then we're using those to help us with the top part. Then you've got the same thing at the bottom, okay? You've got your molar mass of the chemicals and then some practice. All right? So try that out. See how we do.